Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and I would like to be the first to welcome you to Unit 3, mini lesson number 6 on scale factor and scale drawings. Okay, by the end of today's mini lesson, you should be able to use proportions to solve problems using scale models. These are some pretty cool real-world examples of some things we've already talked about in math class, and I do realize that you did take a math benchmark earlier today, so I'll try to keep this video nice and short. Okay. The reason we have to do this today is because we are taking our Unit 3 post-test this Thursday. Maybe you should write that down to remind yourself, okay? Like I said, this is Unit 3 mini lesson number 6, and it happens to be the 10th entry in the table of contents, so please keep that in mind. Please write that in your table of contents if you have not done so yet, okay? We're going to go ahead and get started with today's notes by writing entry number 10 on the top right-hand side of our paper, and then we're going to talk about a couple key concepts. The first thing we're going to talk about is a scale drawing or model. A scale drawing or model is a smaller proportional model of a real object. Two excellent real-world examples would be like a map. That map has a scale in it. Look right there on the bottom left-hand side of it. That's the scale. And then a model car would be another great example of a scale model, okay? Because it is definitely created proportionally to the size of a real car, okay? When people make maps or make model cars or anything like that, they have to use the scale factor. That's the unit rate that's used to make that scale model or drawing. They have to be sure that the smaller version of that real-life object looks just the same proportionally as the larger version of it does, okay? These model cars just look just like their real-life counterparts, and that's really important because this map looks just like the map of the United States if you zoomed out from the globe. Okay, some real-world examples of these scale drawings and models, like I said, or maps, model cars, blueprints, even Barbie houses are created drawn to scale. Okay, the really good news about this is that we're going to use the same ratio, the same proportion every time to solve it. We're always going to use the same proportion every time we try to solve these. Okay, and that is that we are going to take the scale over the actual distance and set it equal to the scale over the actual distance. We're always going to use the same proportion every time we solve these problems, okay? The good news is that one of these parts will be missing, and that'll be our x, and that's what we'll try to find when we're trying to solve these different proportional word problems, okay? This first example says, on a map of Florida, the distance between two cities is 10.5 centimeters. On the map, the distance is 10.5 centimeters. What is the actual distance between the cities if the scale on the map is 3 centimeters for every 80 miles. See how it says that the scale on the map is 3 centimeters for every 80 miles? This first ratio represents that. I put the centimeters over the miles, and this first ratio tells us what the scale on the map is. The second ratio in the proportion is going to use one of the numbers from the top of the word problem that says the distance between the cities on the map is 10.5 centimeters. We're going to put that on the top. Please note that I have centimeters on the top of both my ratios. That will help me keep it balanced and organized. And I'm trying to find out what the actual distance is in miles in real life between these two cities is. That's why I called that x. I don't know what it is yet. If we cross multiply, 3 times x is 3x, and 80 times 10.5 is 1,200. We could divide both sides by 3, just like we've been doing here for a while, and 3 goes into 1,200 400 times. That tells us that based on the map, based on how far away these cities are on the map, and what the scale says about how far away they would be in real life, we can estimate that these two cities are about 400 miles apart. Okay? What you're going to do, okay, is this first example on the right. I just found a typo. There it is. You're welcome. Okay? You're going to try to write a proportion and solve it for that first example, and Edpuzzle is going to ask you what you got. Then when you get to my station, we're going to look at these next two examples, okay? We might even look at some of these examples on the back of your mini lesson as well, okay? Remember, tonight's homework is the study guide, the Ratios and Proportions Study Guide, Part 1. That's tonight's homework. Remember to make it a great day or not. The choice is yours. Thank you and have a great day.